Hello everyone and welcome to ACAD-04, which will be an introduction to meteorology. So today we will be discussing the impacts of meteorology, i.e. the weather, on aviation, and the procedures that are adopted to help manage these impacts. So, let's start off with some altimetry. So we use barometric altimeters primarily to give altitude clearances. So a barometric altimeter will work by detecting the air pressure outside the aircraft, and because of this, they have to be calibrated around a fixed point, which is known as the altimeter setting. And for most purposes, we have three different settings, or three different types of settings. We have the QNH, the QFE, and the QNE. So these codes don't really stand for anything because they originated from radio telegraphy Q codes, which is a rabbit hole and a half if you want to spend 2 hours down Wikipedia, but there are some helpful initialisms that you can use to remember them. So to start off, we have QNH, or Query Nautical Height, which refers to the current air pressure at sea level. When we are clearing an aircraft on the QNH, we use the radio pro word altitude. So in this example 11, descend to altitude 3,000 feet, the QNH 2983. Then we have QFE, or Query Field Elevation, which refers to the current air pressure at either the runway threshold, which we call threshold QFE, or an average of the aerodrome, which we would call aerodrome QFE. The radio pro word that we use with the QFE is height. So for example 11, descend to height 4,000 feet, the QFE 2975. When we are providing the QNH or QFE, we do when an aircraft descends through what we call the transition level, or when they're changing between the two, but we will discuss this more later. We also have QNE. QNE you can also think of as Query Nautical Equivalent, which is the average air pressure at sea level as defined by the ICAO standard atmosphere or ISO standard atmosphere, depending on who you ask. And this is used at higher altitudes to provide a common pressure setting. You may also have heard it referred to as standard pressure. The radio pro word that we use with QNE is flight level, and every flight level is 100 feet. So in this example 11, climb flight level 110. We are asking example 11 to climb to what would show on their altimeter as 11,000 feet on the QNE. The QNE does not need to be given to any pilots, as it doesn't change, and they would generally set it either when cleared above the transition altitude or when passing the transition altitude. The QNE is defined as 2.992 inches of mercury, where when we're transmitting over the radio, we wouldn't pronounce the decimal, so it would be 2.992, or 1013.25 hectopascals. Generally, when we are giving hectopascals, we would not give the last two digits, but that is the full definition. So, transition altitude and transition level. The transition altitude is the point at which aircraft transition from the QNH or QFE to the QNE. And this is always done when climbing. The transition altitude is typically defined either on the charts or in an ATSA broadcast, an automated terminal information service. Then the transition level is the point at which aircraft transition from the QNE back to QNH or QFE. Because of this, the transition level could change, but it is always equal to or higher than the transition altitude in physical space. And due to the different pressure settings, it is important to remember that aircraft shouldn't maintain an altitude within the transition layer, which is what we call the physical space between the transition altitude and transition level. This image might be more descriptive in that, where we go from altitudes or heights, then we climb through the transition altitude, the aircraft switches to QNE, then we go into the flight levels, they cruise, they descend back through the transition level and change back to a QNH or QFE, and are then back in the altitudes or heights. Next, let's talk about cloud coverage. So the cloud coverage is typically given in the ATSA or in METAR's meteorological aerodrome reports. And we have a few different ways of defining it. A completely clear day would be described as CAV-OK or sky clear, depending on who you ask and where in the world you are. And then cloud coverage beyond that is described in octas, which is how many eighths of the sky is covered by cloud. So we have trace clouds or few clouds at 1 to 2 octas, scattered clouds at 3 or 4 octas, broken clouds at 5 to 7 octas, and overcast at 8 octas, where it is completely covered. When cloud coverage is reported, it is given with the altitude of the cloud base. So, for example, the first example here, we have scattered at 5,000 feet, overcast at 9,000, and a broken layer at 2,500 feet. And this could be either in height or altitude, depending on where in the world you are. For some visual examples, we have these images. We have CAV-OK, few, scattered, broken, and overcast. But they are generally relatively self-explanatory. So, when we have very low visibility, be it through a very low cloud base or fog or heavy rain, snow, etc., an airfield will transition into low visibility procedures. The point at which these LVP is entered is typically defined on charts, or in our case in the DCP-151, or correction, the DCP-15 series for every aerodrome. And it's important to have an understanding of this because we have various types of instrument approaches which have various visibility minima. So when we are talking about this, we often talk about runway visual range, which is the distance that you can see down the runway. So here I've given 3 examples of different categories of precision instrument approaches. So you have category 1, which requires 550 meters or greater runway visual range, category 2 at 300, and we also have category 3C, where we have no RVR limitation. We don't typically have anything higher than category 1 or 2 in DCS, but different airfields do have different categories of ILS available in the real world, and to a lesser extent also in DCS. So to summarize what we have spoken about today, we had a look at altimetry and the difference between QNH, QFE, and QNE. We looked at the transitions between QNH and QFE and the QNE, and that this happens at the transition altitude or transition layer, and the space in between the transition altitude and transition layer, transition level, being the transition layer. We also covered cloud coverage and introduced the octas and the different levels of cloud coverage that can be reported. And then finally, we also spoke about low visibility procedures and had a quick introduction to approach minima. Hope that was useful for you guys.